Figure out the values of sine for 30 degrees, 45 degrees, 60 degrees, and 90 degrees. In case you forgot the trick with sine and 30 degrees, 45, and 60, it's 1 over 2, radical 2 over 2, radical 3 over 2, and just 1. Now when I mentioned the trick is this. The first one can just be radical 1 over 2 because square root of 1 is just 1. This one's radical 2 over 2. That's radical 3 over 2. And oh hey, guess what? If you do radical 4 over 2, radical 4 is just 2. So 2 over 2, just 1. Here we have trig identities that are sums and differences of angles. So for example, if you're looking at cosine and you have some angle plus another angle, the other way you could do it is just cosine of the first angle times cosine of the second angle minus sine of the first times sine of the second. Sine also has a rule like this where it's sine of the first times cosine of the second plus cosine of the first times sine of the second. Tangent also has tangent of the first plus tangent of the second all over 1 minus tangent of the first times tangent of the second. Now, they have similar things for differences as well, if you have an angle minus another angle. So, with cosine, it's cosine of 1 times cosine of the second plus sine of the first, sine of the second. Sine, when you subtract these, is sine of the first times cosine of the second minus cosine of the first times sine of the second. This one's a little tricky because you have to make sure you put it in the right order. Sine of the first, cosine second, then cosine of the first, sine of the second. And then for tangent, it's tangent of the first minus tangent of the second, all over 1 plus tangent of the first times tangent of the second. This can become helpful if you have a problem that's asking for like sine of 75 degrees. Because up here, there is no 75 degrees. However, I know what sine of 30 degrees is, and I know what sine of 45 degrees is. So, if we go over here, you can just pretend that this one is 30 degrees, this one's 45 degrees, and then follow the rule to solve for the exact value. In this example, we're solving for sine of 15 degrees. Now, the easiest problems to use here, I would just use 45 minus 30. Of course, you could do 60 minus 45. It would get you to the same place. So let's just pretend that this actually says sine of 45 degrees minus 30 degrees. And then we're going to use this formula right here. So, start off with sine of the first times cosine of the second minus cosine of the first times sine of the second. Now we're just going to plug in values from the chart here. I got these just by looking at 45 degrees, for example, and then finding sine 45, and then that's how I plugged all of these in. Now the last part here, we just have to simplify it. So radical 2 times radical 3 is radical 6 over, then we multiply the bottom, 4, minus radical 2 times 1 is radical 2, all over 4. And then this just equals radical 6 minus radical 2, all over 4. And that is the exact value of sine of 15.